Okay, in this video, we're going to find the differential and evaluate for the given value of x and dx. So the differential formula is given by dy equals f prime of x dx, or dy equals dy dx times dx. And so what dx is a small change in x, and then dy would be a linear approximation for the small change in y, and then dy dx is the rate of change evaluated at, say, number 73, x equals 1. So if you think about this as, say you're driving down the freeway and you have a small change in your input of time, and then you multiply by the rate, how fast you're going, and you can find a small change in the distance. So we do it all the time. Take a small change in time, multiply by an approximation of the rate, and you get a small change in the output, a linear approximation. But that's a whole other, explanation. I boiled that explanation down to a little few sentences. But all right. But the thing about these problems are essentially we need to find the derivative and use a formula. So it's simply, like an application, for us at least doing this, an application of derivatives. And so what I did is I wrote x plus 1 to x plus 1, or 1 over x plus 1, I wrote as x plus 1 to the minus 1 power. That's what I just did there. 1 over x plus 1 is x plus 1 to the minus 1 power. Take the derivative using the power rule. Bring the negative 1 to the front. Negative 1 minus 1 is negative 2. You can multiply by the derivative of the inside, which is x plus 1. And but that's just 1. So there we go. And so with dy, according to our formula, is the derivative, which is negative 1 over x plus 1 squared times dx. That's our differential formula. Now let's use it to calculate a linear approximation for a small change in x, it's a linear approximation of a small change in y when we have a small change of x of 0.25 and add x equals 1. So 0.25, dx equals 0.25 is 1/4. So dy is going to equal negative 1 over 1 plus 1 squared times 1/4. And that's going to be negative 1/4 times 1/4, which is negative 1 over 16. So when you have a small change in x of 1/4 from x equals 1 to x equals 1 plus 1/4, you have a small change approximately of negative 1/16 in y. All right, for this next one, we're just still going to plug into our formula here, which I can copy and paste once again below. Let's just bring that down here. Put in purple maybe. Okay. So I'm going to use the formula. So I find the derivative of tangent, which is secant squared x. And so therefore dy is the derivative secant squared x times dx. I mean, you can really even just do this directly from the statement here, y equals tan x. You just take the derivative sort of in a funny way. You write dy equals derivative tangent x, secant squared x times dx. That's how you find the differential. So that first line I didn't really need there. Okay, then we're going to put in x equals 0 and dx equals pi over 10. All right, almost wondering if I wrote that problem down wrong, but okay. So dy is then going to be secant squared 0 times pi over 10. Okay, now let's just, on our side here, let's just remember that secant squared 0 is equal to 1 over cosine squared 0. And cosine squared 0 is equal to 1. So secant squared 0 is 1. So this becomes 1 times pi over 10. So if if we begin at 0, at x equals 0, and you change x by a little bit, by pi over 10, then y equals tangent x will approximately change by pi over 10 also. Okay. So that finishes this video.